Good morning and welcome to the second part of data visualization using pyplot. In the previous part, we discussed about what is data visualization, what is Matplotlib and pyplot, how can we install Matplotlib, what is a line chart or a line plot, how to create a chart and save it, line chart with multiple lines, and how can we change the color and style of a line chart. So those of you who have not watched the first part, please do watch it so that understanding of this part becomes easier. In this part we'll continue with line chart. The next topic in line chart is subplots or multiple views. These are nothing, basically subplot is more than one chart in one window. Sometimes it is helpful to compare different views of data side by side. For this, Matplotlib has the concept of subplots, groups of smaller axes that can exist together within a singular frame. These subplots might be insets, grids of plots, or other more complicated layouts. Basically, subplots are needed when you want to compare a particular thing over a period of time. Say, for example, you want to see sales made by a person in 2019 and sales made by him in 2018. If you see both the charts side by side, it will be easier for you to make analysis on that. So that is where we will be using subplot. Now we can have a subplot using this function plt.subplot. It takes three arguments. The first argument is the number of rows, the second argument is number of columns, and the third argument is optional, which is the first chart or the second chart or the third chart. Say in this example I have two charts and I want to see them in two rows. So I've written 2 for row, 1 for column, and this is the first chart of the figure, 2 rows, 1 column, and this is the second chart of the figure. To understand it better, let's see a practical of it. Okay, here I have already written the program to save time. We have imported matplotlib.pyplot and we have imported numpy. Then I have taken a variable t in which I have stored some numbers using the arange function of numpy. I hope you remember the arange function. For those who do not, I will have a quick recap of arange in a while. This line, what this line will do, it will give me numbers from 0.0 to 19.0. Okay, so the numbers that will be stored in T are 0.0, 1.0, 2.0, 3.0 till 19.0. Then I have two more variables, S and S2. In S I have some numbers here, in S2 I have some more numbers here. Then using the subplot function, I am creating a subplot with 2 rows, 1 column, and this is going to be the first chart of the subplot. I've given name to label to the y axis. I've given title to the chart. This commented line I'll explain you in a while. And then I'm plotting the chart with T and S, so with these numbers and with these numbers. This also I'll explain you in a while. Then this is the second subplot where I've given X label, Y label, title of the chart. I'm plotting the chart and then I'm writing plt.show. So let's see how the chart will look. Okay, you can see the chart here. There are 2 rows, 1 column. This is the first chart which is given by this code. This is the second chart which is given by this code. There is less space between the 2 charts and there is little bit of overlapping here, so I cannot see the numbers properly and I cannot see the title properly. Now if you remember, when I was explaining you these buttons, we were talking about configure subplots, and in that the last 2 options I kept pending, which is W space and H space. Here W space stands for width space and H space stands for height space. Height space means the space of height between the 2 rows. So if I increase this, the space over here will increase and then I can see both the charts clearly. So width space means the space of width between 2 columns. Now we do not have columns, so I cannot show you width space here. I'll show you in the next example. So this is the height space, means the space of height between the 2 charts. So this is subplot where we can have number of rows, we can have number of columns, and we can have more than 1 charts. Here I had written 2 rows, 1 column. Now let's change it to 1 row and 2 column, and then see how the chart will look. It's the same chart, but this time I will have the view side by side like this. This is the first chart and this is the second chart. Here I can show you the width space. If I increase this, the space between the 2 charts will increase. That is, the space of width between the 2 charts will increase. Now every time I run the chart, I have to do this manually. If I don't want to do it manually every time, I can also write it as a piece of code. That is this plt.subplots_adjust, and you can give value for H space and W space. Here we have got the space between 2 charts. We can use subplots not only for 2 charts, we can have as many charts as we want. See, here we have 2 charts, but I've also written code for more charts. I'll just remove the comment from this piece of code. Now I have 4 charts with the same values, of course. This is the first chart. Now because I have 4 charts, I want to see them in 2 rows, 2 columns, and this is the first chart. I want to have 2 rows, 2 columns, and this is the second chart. 2 rows, 2 columns. This is going to be the third, and this is going to be the fourth. Let's see if it works. I have 4 charts now. I can increase the width space here and I can increase the height space here using this function again over here. So we can have more than 1 chart. Here we are having 2 rows and 2 columns. This is called subplots. Now in this, one thing which I had commented was plt.greed into bracket true. This piece of code will be giving me the grid lines in chart. Grid lines are used to see the chart in a better way. It will give you small squares so that you can see the details properly. Now I've written plt.grid true for this and I've not written it for this. So let's see how the grids will look. If you can see, this chart has small squares, so you can see the chart more clearly, whereas this doesn't have it because we have not written grid true for the second chart. You can add it by writing plt.grid into bracket true. The T of true should be capital, and because it's a constant you don't need to write it in single quotes. We have grid for both the charts. When I move my cursor over the line, concentrate on this part of your screen, the bottom of the screen. It is going to show me the exact value of x and y for that point where my cursor is. Say my cursor is here, so the value of x is something here and the value of y is this. As I move the cursor, these values also moves automatically. This is for better analysis. So this is all about subplots. We can have a subplot using the subplot function. It takes 3 arguments. The first argument is for number of rows, the second argument is for number of columns, and the third argument is optional, which is the chart number. This is the first chart, second chart, third chart, and so on. So hope the subplot is clear. We also discussed about the subplot underscore adjust function, with which we can adjust the width space and the height space. Width space is the space between 2 columns, height space is the space between 2 rows. The arange function, which I said we will have a quick revision. Arange function is in the NumPy library. It is used to get numbers. It takes 3 to 4 arguments. The first argument is the start, the second argument is the stop value, the third argument, which is optional, is step value, and the fourth argument is also optional. It is the data type value. Let's see some examples. If I write 0, 20, 2 means I want numbers from 0 till 19. It's going to give me one number less than what I write here, with an interval of 2 numbers. So what I'll get is 0, 2, 4, 6, 8, 10, 12, 14, 16 and 18. I can also have numbers in reverse order. So 20, 1, -1. This is going to give me numbers in reverse order. So this is the arange function, which takes 3 or 4 arguments. The first argument is the start, the second argument is the stop. Whatever value you write for stop, you will get 1 less than that. Here we have written 20 for stop, so the last value we will get is 18 and not 20, because we have an interval of 2. And here we are having it in reverse order. So our start value is 20, the stop value is 1, so I'll get 1 less than that. That is why the last number I'm getting is 2. and the interval is -1. I've skipped the last argument, which was the data type. By default, the data type of this is integer. So I hope the arange function is clear. Let's see some more examples of line chart so that we can move to the next topic. Okay, this is a frequency distribution chart where I have, in the list I have few numbers. I have 53 times, I have 65 2 times, I have 75 2 times, I have 80 2 times, and I have 94 times. Then I'm plotting these numbers using the plot function. Using the title, I'm giving the title to the chart, that is marks line chart, and I'm giving labels for x-axis and y-axis. So this is how my chart's going to look. This type of chart is called frequency distribution chart. You can see this line over here for 90 is 4 times longer because 90 is 4 times. 50 is 3 times, 65 is 2 times, 75 is 2 times, 80 is 2 times. So these type of line chart is called frequency chart. The next example is line chart which will be used to show a sine wave. I hope you know what a sine wave is. It is a mathematical curve. It describes a smooth periodic oscillation. I'm just showing you different situations where you can use a line chart. So this is a sine wave. We've got this chart using the line chart function, that is the plot function. Okay, next example is with the help of a line chart we will be getting algebraic equation. We'll be using an algebraic expression to get a line chart. The algebraic expression here is 10x plus 14 and the values of x are 12, 20. Now here you can see the third option, the third argument is missing. So the step between numbers will be 1 by default. So the numbers which will be stored in x will be 12, 13, 14, 15, 16, 17, 18 and 19. Each of that number will be replaced in x here and the values will be stored in y. Then using the plot function I am plotting x and y. I have given title, label, so this is a line chart to show an algebraic expression. And the last example here is to sum up everything in line chart. Like in line chart we can plot the values, we can change the color of the lines, we can change the shape of the line, the style of the line, not the shape. So here you can see I have 3 lines. The first line is the first line is red and it is a dashed line. The second line is yellow and it is a dashed dot line, and the third line is blue, it is a dotted line. So this was all about line chart. The next type of chart is scatter chart. A scatter chart, also called a scatter plot or a scatter graph, uses dots to represent values for two different numeric variables. The position of each dot on the horizontal and vertical axis indicates values for an individual data point. Scatter plots are used to observe relationship between variables. We can have a scatter plot using the scatter function. The line chart we used the plot function. Here we are going to use the scatter function. Let's see some situations where we can use a scatter chart. Basically, it is used to identify potential association between two variables. A scatter XY plot has points that show the relationship between two sets of data. In line chart, we had a line to show the relationship. Here we will just have dots. It can be used, some examples are a scatter chart where each dot shows one person's weight versus their height, sale of ice cream at different temperatures of the day, sea level over years. So this is one example of scatter chart where each dot represents sea level from 1993 to 2011. Let's see how we can make a scatter chart. The example that we are going to study here is to plot scatter chart for height versus weight of students. I have already written program. Import matplotlib.pyplot as PLT. Then in the weight array, I have weight of all students. In the array called height, I have height of all the students. It is necessary to have equal values for weight and height, equal number of values. I'm not saying that if it is 83.3 here, it should be 83.3 here as well. No. What I'm trying to say is, if there are 15 values in this array, there should be 15 values in this array as well. If there are 15 in this and if there are 14 in this, you will get an error. So there should be equal number of values for both the axes, because here weight we will be using as x-axis and height we will be using as y-axis. So it is necessary to have equal number of values in both the axes. Then only we will have a corresponding point. Now using the scatter function, I'm plotting the values of x and y. In x will show the weight and the y-axis will show the height. The color I'm going to use for dots is R, which stands for red, and I put a star here which is called a marker. I'll show you what exactly a marker means. Then I've given values for X label and Y label. This is the title of the chart. I'll come back to this font size a little later. Let's see how a scatter chart looks. The chart has scattered points. Because we used R, all the points are red in color, and I have used a star here, means I've got asterisks as points. I can change the shape of these points and I can change the color. Here I have written font size equals to 50, which is for the title. That means the size of this title. Let's try to increase and decrease it. If I write 9, I hope it's visible. See, the title has come in a small, because in small value, because we have written 9 here. If I increase it, the font size will increase. So this is one more aspect we have learnt in chart, that is the font size of any label. It can be used for the title, it can be used for axis label, it can be used for y-axis label, it can be used for legends. We can use font size for any of these. And yes, I've talked about markers. Now marker is the shape that is used to show the points. We have different markers. Color aberration is same as what was there for the line chart, where B is for blue and so on. Remember, black we can get black with K. Marker styles. We had used asterisk, that's the star, but we have lot of other styles. If you write S, you get squares. If you write O, you get circles. Up triangle, down triangle, right triangle, left triangle, D for diamond, pentagon. Shall we try some of these? Let's change it to right triangle. The points are of that shape. If you change it to O, you will get a circle. So these are markers, the style of marker. Let's see one more example of scatter chart, where the points will be scattered randomly. Okay, here I have imported NumPy because again I am using a function from the NumPy library. This time the function I am using is random. This is going to give me random numbers. np.random.randn is going to give me float random numbers from 0 to 999. Because I've written 1000 here, it is one less than what I write here. So in X I will be having 1000 random numbers, in Y I will be having 1000 random numbers between 0 to 999. Then I'm plotting those numbers using the plt.scatter function, and then I'm showing these three what I've commented. I'll just show you in a while. So I've got 1000 random numbers. See here, I had not given any value for color or shape, so that means by default the color is blue and the shape is circle. You can add color and shape here, that we can see in the next example. And okay, here I don't want to limit the output to a single color or a single size. So I've taken two variables. The size variable I've taken for size, and color variable I've taken for color. In size again I am having some random numbers, and in color again I am having some random numbers. Now colors can also be represented with numbers. We use letters like R, S, R blue, B for blue, Y for yellow, R for red. It's because it's easier to recognize. You can also have same colors with numbers, but it is going to be very difficult to remember which number represents which color. But we have used it over here because we want just different type of random colors. And the shape I have used is a up triangle here. So the chart I will get is a beautiful chart of 1000 dots. Each dot is of a different color and a different size. Of course, you can change the shape. Let's make the shape as P. I think P was for pentagon. Yes, we've got 1000 pentagons here, each of a different size and color. The size and color was decided by pie plot because we gave these two options here. S is equals to size and C is equals to color, where in size I had kept some random numbers and in color I have kept some random numbers. So I hope scatter chart is clear. Let us move forward to one more type of chart, which is called a bar chart. This is most popular chart. You must have done a lot of bar charts in Excel. A bar chart uses bars to show comparison between categories of data. These bars can be displayed horizontally or vertically. A bar graph will always have two axes. On one axis will generally have numeric values and the other will describe the types of categories being compared. Say for example, on one axis you can have names of students and on the other axis you can have percentage achieved by them. Bar plot can be done using the plt.bar function. So I am again repeating, for line chart it was plt.plot, for scatter it was plt.scatter, for bar it is plt.bar. When to use a bar chart? A bar chart are often used when comparing categories of data, which can see data changes over time. For example, sales made by a person in 3 months, or smartphone use over a period of time, or comparison of marks of 5 students. And this is how a bar chart looks. You can see these are the bars. Each bar is of a different color. On this axis we have names of the salesperson. On this axis we have sales made by them. This is where we can use a bar chart. Let's see an example of bar chart. Again, I have written the code to save time. We imported Matplotlib and NumPy. In the X array, I have names of programming language like Python, C++, Java, Perl, Scala and Lisp. On y-axis I have the usage. Then I am plotting them using the plt.bar function, x and y, and color I am using is R, which is for red. X label is languages, Y label is usage. You can also have font size here if you want a different font size than the default one. The title is going to be Programming Language Usage. So this is how a bar chart looks. We have bars for different languages. On x-axis we have names of the language, whereas on y-axis we have their usage. You have labels here, you have title here, and as I move my cursor over different bars, I'm getting their values over here. In the same bar also there are different values. Let's see one more example of bar chart with more than one bar. Here, X and Y I have used for one type of bar, X2 and Y2 I've used for second bar. Then because I want more than one bars in my chart, I'm using the bar function multiple times. It's same as you used the plot function multiple times to get more than one lines. Here we are going to use the bar function multiple times to get more than one bars. The first bar is blue in color. We have enough of red, so let's change it to yellow. Then I have labels and the title of the chart. Then I have legends. Because there are more than one bar, I need to show to the user which bar stands for what. So this is how a bar chart with multiple bar looks. We have got legend where blue is for first type of bars and yellow is for second type of bars. You can see the title has come up in multiple lines. It's not a single line title because I have used a backslash here in the title. Okay. If say first bar is for marks and the second bar is for subject, just by changing the label here, the legend will change on its own. Okay, I changed the label there in the program. I've got the change here in the legend. So this is about bar chart. If you want to have more than two bars, you can have you will just have to use the bar function more than one time, more than two times or three times, or as many bars as you want. So that was all about bar chart, and we have come to an end of this part. In this part we studied what are subplots of line chart. In subplots we studied W space, which is width space, H space, height space, and grid. We had a quick revision of the arange function. Then we studied scatter plots or scatter charts and bar graph. In the third part, which is the last part of this chapter, we will be studying histograms and box plots. Pie chart are not in your syllabus. Still, we'll try to cover pie charts there. So I hope you have understood everything that I've taught in the part 1 and in the part 2. If any one of you have any doubts, you're most welcome to contact me. By now, all of you would have my number already. If you don't have, please contact your housemasters. They'll give you my number. See you soon with part 2, part 3. And because you don't have textbooks, I have written detailed notes of this chapter, which I will be uploading on the Google Classroom soon. So keep checking there as well. Thank you and stay safe.